Okay, everyone. Here we're going to look at a couple problems where we have to identify the relative mins and maxes and describe the intervals of increasing and decreasing. I'm going to go through this kind of quickly because we did this in class, so I just want to give you some example problems and their solutions. So again, this first one asks for a relative min right here, a relative min. Um, well, when we first come to a graph, if it looks like it goes to the edge of the screen, that means we want to put the arrows on. And those arrows mean that the graph is going down towards negative infinity for the range, and the graph is going to the right for positive infinity for the domain. Similarly, on the left side, the graph is going down toward negative infinity for the range, and it's going to the left for negative infinity for the domain. So that will help us at some point, especially when writing the intervals. When it says what's the relative min, well, look at the graph. It's going down to negative infinity on both parts right here. So because it's going towards negative infinity, there is no relative min. There's no point where the graph goes from decreasing to increasing. Now there is a maximum, a relative maximum right here where the graph goes from increasing to decreasing after that point. So that point is a relative max, and we can describe those coordinates as -2, 4. So the relative max is -2, 4. And I also say we're not going to really look at absolute mins and absolute maxes this year. That's a topic you'll see in calculus. And so anything that involves absolute mins and maxes, we're not actually going to take a look at. Where's the increasing interval? Where is the graph increasing? So where is the graph going up from left to right? So we see that the graph is increasing on this interval, and we always describe the intervals using our x values. So from negative infinity all the way until -2, that x value, the graph is increasing. So let's write that. From negative infinity until -2, the graph is increasing. And we use parentheses here. We'll always use parentheses for increasing and decreasing intervals. And that's because at the point -2, 4, at this point right here, the graph is not increasing or decreasing. The graph is really just constant. So that's where it changes. So we use intervals to show that -2 is not included. And then where is the graph decreasing? The graph begins to decrease after that point. So we would say that the graph decreases from the x values starting at -2. Again, we use the x value all the way until positive infinity right there. So -2 to infinity, the graph is decreasing. Where is the interval? Where is the graph constant? There are no constant intervals where the graph is constant for a time. And again, if we describe the domain and range, all x values and all y values, the domain is going to go from which values? From negative infinity to positive infinity. That's our domain. And our range goes the other direction. And our range, again, is our y values. And that's the interval goes from the smallest y value, starting at negative infinity, all the way until 4. That's our largest y value. We can't really say negative infinity is our smallest because negative infinity is not a number, but it is a quantity representing the absolute extreme of our range. And then our x-intercepts, where does it hit the x-axis? So if we mark the coordinates of these points, 0, 0, And the coordinates of this point on the left where it crosses the x-axis, we have -4, 0. So where it's crossing the x-axis, the x-intercepts, we just list the x-coordinates at -4 and at x equals 0. Right here and right here. And then our y-intercepts is where it crosses the y-axis, and we just list the y-coordinate, and that's going to be right here, the y-intercept at 0. Okay, so that is defining the various characteristics for this graph right here. Thanks for watching.